The next section we're going to talk about involves a concept called electric potential, and it has the same relationship to potential energy that fields have with forces. We assign the property of potential to the space, and then we calculate the nature of the potentials, and then we place objects that have charge in the field, which gives them a certain amount of energy. So we're going to start out with an energy review, and I want to point out that the first section of the chapter is a very good overall review of energy concepts, and you should definitely look at it and think about it. I'm going to focus on a very small part of that review so that we can get started. And the first thing is that potential energy is the result of location in a force field. This is a different way than the way that we thought about it before in terms of action at a distance and forces, and two objects exerting forces on each other. So there is a little bit of injection of field theory into this layer. And we say that the energy is stored in the field, which is different than our first semester concepts of potential energy, where we just looked at the positions and we didn't think about where we're going to store the energy, where the energy actually is. And again, quick reminder, this is all just a mathematical construct that allows us to make accurate predictions. None of these things, energy, etc., have a real objective existence independent of us thinking about them and using them to describe the actual world. So it's a mistake to assign physical reality to these things. The change in potential energy between 2 points is a result of the work done on the object by the force field if it moved between those 2 points. So we can write that out in a formulaic way for a constant force or an average force simply as F dot S. The reason we have a negative sign here is that if the field is the one doing the work, then there is a decrease in potential energy. If the work is being done by an external agent, there's an increase in potential energy. So we need the negative sign there to fix that relationship. Again, the whole concept of on and by and what is creating the force and what is doing the work, you need to clarify that in your head. It's really something that comes from thinking about it, but it is very important. And then we also have the integral form of that, where the change in potential energy is the sum of the work done. And here we can have a combination of variations in forces and variations in displacements, and we sum the individual contributions.